Everyone, welcome to Last Minute Maths, and in this video we're going to work our way through quadratic sequences for GCSE, finding the nth term for a quadratic sequence. All right, we're going to dive straight in, and I've got an example here already. So you've got a sequence of the first 5 terms, so 2, 10, 22, 38, 58. All right, the first thing to do with this is to check the differences between the numbers. All right, so between 2 and 10, the first 2 terms, you're looking at 8. All right, and then the second 2 terms, 10 to 22, 12, and 22 to 38, 16, 38 to 58, obviously 20. All right, so that is known as the first difference. I'm going to do it in short form. All right. The first difference, as we can see, is not constant. And that means that it is not a simple linear sequence, right, where it's increasing by the same amount each time. Okay. So if you find one of these and the differences keep changing, then you go to the next level, what's called the second difference. And effectively what you're doing is finding the difference between the differences. All right, so if that doesn't make sense quite, just see what we're doing. So you go to 8 to 12, you're adding 4. All right, 12 to 16, 4. 16 to 20, it's also 4. So this is known as the second difference. All right, and that now is constant. Okay, so if the second difference is constant, as we can see, 4 each time, that means it is a quadratic sequence. All right, so that proves that it is quadratic. Okay, what does that then mean? All right, it means that the nth term for this sequence will have the form of a standard quadratic. an squared bn plus bn, that is plus c. All right, so again it's based on n. N is the position value, and I'm going to write that down. Okay, sorry, there we go. All right, so n is the position value. Now what does that mean? This value number 2 here, right, is the term itself. It's the first term. So that means n equals 1. All right, so when n equals 1, the value of the term is 2. N equals 2, the value of the term is 10, and so on. All right, so n is the position, what position a particular term is in, that particular value is in, right? And that's n equals 5. Okay, so the n here, n equals the position. So if we're talking about the 10th term, whatever that value might be, then n equals 10. All right, so we need to work out what a, b, and c are in order to find the general nth term for this sequence or any other quadratic sequence. All right, the first rule that we have to note, and this is very first thing, a, the first coefficient, the coefficient of the n squared, a always equals half times the second difference that we found. All right, so in this case, remember we found the second difference is 4. All right, so this particular example, a in this example equals half times 4, and that's 2. All right, so we have the first coefficient straight off, and that's always the method. whatever the second difference is, halve it, and that gives you a, the coefficient of the n squared. All right? Okay, next step. What we're going to do is, let's start with a value n equals 1. When n equals 1, the first term we know equals 2. All right? So if we put in, as we know already, by the way, a equals 2, right? So 2n squared plus bn plus c is what we're going to use. All right? And that is going to equal, what's the best way to write it? No, let me change that. Okay, so 2 times 1 squared plus b times 1 plus c equals 2. That's our first term, right? The value of the first term. Tidy that equation up and you get 2 plus b plus c equals 2. Therefore, b plus c equals 0. All right, so that's our first equation that we've got. Okay, then next step, use n equals 2. All right, for that, we know that the second term equals, looking back at the thing again, right, 10. Okay, so you can see it there. Equals 10. So again, just substitute n into our general quadratic. So we have 2 times 2 squared, pardon me, plus b times 2 plus c equals 10. Tidy that up again, and you've got 8 plus 2b plus c equals 10. Simplifying that, you've got 2b plus c equals 2. All right? Oh, apologies. Tidy that up a little. Hang on. There we are. 2b plus c equals 2. All right. So, having got those two equations, it's literally like treating it as if though they were simultaneous equations. But if you use n equals 1 and n equals 2, as I have done, all right, and you write the two equations sort of over each other. So let's say b plus c equals 0 and 2b plus c equals 2, right? We don't actually have to go through the whole simultaneous equation method, because you can see the only difference is that is 1 extra b has been added. All right, so we went from b plus c to 2b plus c. All right, so effectively the difference between the two equations, so effectively you've gone plus 2, and on this side you've got a plus b effectively, right? So that tells you that it is b equals 2 straight away, right? And from there, I suppose I have to explain it just a little bit more. Since we know that b plus c equals 0, then knowing that b equals 2, 2 plus c equals 0, therefore c must equal minus 2, all right? And if you need to, go back and prove this point here by doing it in the simultaneous equations method, if you will. But whenever you use n equals 1, n equals 2, comparing those two simplified versions with just b and c in them, all right, will tell you straight away what the value of b is. All right, so now we know what a, b, and c are. Therefore, the nth term equals 2n squared plus 2n minus 2. All right. And if we want to test it, so that's actually the answer. If we just want to test it, in case you have time in your exam, if you don't, then you probably don't need to. Let's take n equals 3, and the sequence, the third term, let's remind ourselves, was 22. All right. So there, n equals 3, the third position, third term is 22. All right, so let's see what we get when we put n equals 3 in there. So 2 times 3 squared plus 2 times 3 minus 2. So that's 18 plus 6 minus 2 equals 22. There we go. So that's proved. All right. So quick recap, just to make this short and sweet. For quadratic sequences, first of all, prove that they are quadratic by doing the second difference. All right. The first one will not be constant. The second one should be. If they ask you to do that, find that second difference. In this case, it's 4. That will tell you what the coefficient of the n squared is. So a will equal half that second difference. And you're looking for a quadratic expression, an squared plus bn plus c. So a you get very easily right from the beginning. Then use the terms, i.e. the first term and the second term. All right. So n equals 1 and whatever the term value is, and then n equals 2 and whatever that value is, and compare the two expressions you get, and that will help you work out b and c, and that's the rest of the quadratic done. All right. So hopefully that has been useful as a very, very short and quick explanation for quadratic sequences. All right. If you find it useful, please do subscribe. And if you have any comments or questions or would like any other topics, then do leave it in the comments and I will get back to you on that. Thanks for watching.